slides in the files. All right, so let's say that we are going to do a hypothesis test now. Here's an example. I'm just going to jump right in, and we're going to look at the difference between the mean, the population mean of one population, so mu1, and the population mean from another population, mean 2. So mu1 minus mu2, that's what we're trying to have a sampling distribution of, and that we know the standard deviations from those populations. So let's do an example, maybe golf balls, and we're going to take a look at, here, let's read this. Based on the data from a previous driving distance test, there's 2 populations. One is Par Inc., that's one type of golf ball. The other is Wrap Limited, that's another type of golf ball. So we've got a sample size that we pull from Par, that's 120 balls, a sample that we pull from Wrap, that's 80. We can calculate the mean in each of those samples, 295, 278 respectively, and then we are given sample standard deviations, 15 yards for population 1, 20 yards for population 2. So the hypothesis test that we want to do is, can we conclude, using an alpha level, a significance level of 0.01, that the mean, the average driving distance of Par golf balls is greater than the mean of Wrap. So we're comparing how good these golf balls are in terms of how far they go in yards. Something that really might be happening or we want to do. So just like before, we're going to have to come up with null and alternative hypotheses, but they're slightly different now. See, there's more going on here. Left-tailed, you're still going to have the less than sign in the alternative. And what are we looking at? We're looking at the difference between the mean 1 and the mean 2 from the different populations. And this D here is the difference, right? So it's that we want the difference of 1 minus the mean from population 1 minus the mean from population 2 to be less than the difference, greater than or equal to the difference. And by the way, we usually just use 0 there. Right-tailed, here you go, two-tailed. The test statistic gets more complicated, but we just use our calculator. We can now go to calculator and go to stats, test, and do a 2-sample z-test. And we're just going to input all the different things, the population, the sample standard deviations, the population standard deviation, the sample mean, the sample size. Calculator will do it for us. All right, let's do it. So we developed the hypothesis. Our alternative is that population, the mean from population 1 minus the mean from population 2 is greater than 0. Do you see how that means that population means 1 must be greater than population mean 2 by putting it greater than 0? And then the null is the opposite with the equal in the null. And so in words, you can see here I've got what the mean distance is of each one. We've got our alpha level here. What is the test statistic? Remember, we don't have to do this by hand, but if we want to, this is how we'd come up with our z-score. There's a z-score just like we would do if when we had our one population test. And by the way, you'll get a z-score of 6.49. But you just put it all into your calculator, you'll get the same thing. And then what's nice is it'll pop out for you what the p-value is. Remember that step 4, first step, null and alternative hypothesis, second step, alpha level, third step, calculate the test statistic, fourth step, the p-value, and then fifth step, determine whether to reject or accept, or I should say reject or do not reject. But remember, the calculator just pops out the test statistic and the p-value for us. So here, I got a really small p-value. I got 4.5 to the 11th. So when you have that low of a p-value, when your p-value is that much less than your alpha, right? Our alpha was 0.01, that means we're going to reject the null. So if we want to put it into words, saying that we're rejecting the null, we're saying at the 0.01 significance level, the sample evidence indicates that the mean driving distance of Par golf balls is greater than the mean driving distance of Wrap. How did I get that? I have to go back and look at what we set up for our null and alternative. We're rejecting the null, that it's less than 0, and therefore accepting the alternative that it's greater than 0. So our mean population's average driving distance is greater. That's how these tests go. So same format. Okay, we could also do this when we don't know the standard deviation from the two populations, and it will be a test statistic that we use the t-distribution. Here, a slightly different test statistic. We're using the sample standard deviations. Again, our calculator is going to help us. What's an example? Maybe we've got Motors of Detroit. It has a new automobile known as the M car. It makes 24 M cars, 28 J cars. Those ones are actually from Japan. And we tested them on their miles per gallon. And here we have some sample statistics. So our sample statistics here, we've got, oops, sorry everybody. Let me see if I can move this around a bit. Our sample standard deviation, for example, I'll put myself up here. So M cars, 24 cars, J cars, 28 cars. You're going to put that in as your N1 and your N2. Sample mean, this is your X1, 29.8, your X2, 27.3. And then we've got our sample standard deviation, our S1, our S2. So we're just going to go to the place in our calculator, stats test 2 sample t-test. That's all that we're going to do. And we're doing it at the 0.05 level. Don't forget that you also have to decide what type of null and alternative to do. Is it a 2-tailed test, a 1-tailed test? So that's what they're asking us here. Can we conclude, using a 0.05 level of significance, that the miles per gallon performance of M cars is greater? With the greater, we know it's not going to be a 2-tailed test. The greater is going to go in our alternative hypothesis. So we're going to be doing a right-tailed test when we enter everything into our calculator. Here we go, right-tailed test. The average of population 1 minus population 2 is greater than 0. That's our alternative. The default is the opposite. So we could go through our tests. Here's, our steps of the test, 0.05 alpha level. Here is the test statistic I get. Again, calculator does it for us. What is our p-value? Okay, a little thing I need to tell you is with a t-test here, it's going to ask you about pooling or not pooling. We do not want to pool, and I'll show you why in a minute. So we call it unpooled. It's just something you're going to choose as you go through the different calculator commands. So when we have a t-score of 4.003, we are going to find that we have a p-value. I should just tell you here, it's going to be, excuse me, I'm just going to do this. Our p-value is going to be less than 0.005. That's what I get. So that's pretty small. That's going to be less than our alpha level. We are going to reject. So here we go. Let me just tell you what it means, pooled versus not pooled. So pooled is when we're taking some sort of variance estimator and we use the denominator of the test statistic and assume the two populations have equal variance. It's not very common that this will happen. Most of the time we're going to use unpooled, and that's when we don't assume they have equal variances. There's no reason in these cases to assume there's an equal variance or standard deviation. So choose unpooled. So there's my little plug for that. So let's go back to our test. What did we see? We saw that we had such a low p-value, it was lower than our alpha. We are going to reject the null. And what does that mean? It means that at a significance level of 0.05, or we could say that we're at least 95% confident, do you see how those are the same things? That the miles per gallon of M cars is greater than the miles per gallon of J cars. And that's coming from the null that we set up, right? We set up the null here and the alternative here. The alternative was that they were greater. We did reject the null, which means we accept the alternative. Okay, one more thing to talk about here. Well, actually, there's two more. So we want to talk about a matched sample, and this is where we have samples pulled from the same population. And then we can just calculate a difference, and we'll do just like a one-sample z-test. So let's say we have a Chicago firm, and it has documents that have to be quickly distributed to their offices throughout the U.S., so they decide between two delivery services, United Parcel Express and International Express. And then we want to do some sort of testing. So we look at the delivery times of the two services. And so they're going to the same offices. That's the key here. So and we're going to do it at the 0.05 significance level. So I think it'll become more clear when I show you what it looks like here. So what we're saying is the samples are matched in that they're going to the same, they're going to the same district offices, so we can compare them. So the samples can be compared. I think I said the population's the same. It's different providers, but we can compare the samples. So like let's say the delivery time in Seattle for UPX is 32, the delivery time in Seattle for Intex is 25. We can calculate the difference, 7 minutes, etc. Then we can just use the difference column. That is what we would put into our calculator, and that is what we could calculate a sample standard deviation for, a sample mean for, and then we would just do our one sample z or t-test, probably in this case a t-test because we don't have the population standard deviation. So here's what our hypothesis would look like, and then we could just go through and do stat, test, one z-test. In this case it's going to be t-test, right, because we don't know. All right, and then we're going to input the differences, do the whole calculation. In the interest of time, I'm going to go through one more thing and show you that we can also do this kind of two population thing for proportions. So here, let's do an example with proportions. We've got market research associates. They're conducting research to evaluate the effectiveness of a client's new advertising campaign. So they want to look before the campaign began and do a survey, 150 households, do that in the test market, and it showed that 60 households were aware. And then they do a new campaign, and what do they find when they do this new campaign after doing it for 3 weeks? They conduct a survey afterwards, and they see that 120 of the 250 households were aware. So we have, a before and after proportion that we're going to be comparing. So it's much just like we were doing for the raw numbers, mu1 minus mu2. Now we'd be doing p1 minus p2. Can we conclude at a 0.05 significance level that the proportion of households aware of the client's product increased after the new advertising campaign? So increase tells us it's going to be not a two-tailed test. We're not saying if they are different or not. We're saying if it's greater. We put that into our alternative hypothesis. We're going to have a right-tailed test. This is what it'll look like. So our alternative hypothesis, P1 minus P2 greater than 0. Our null is the opposite. And by the way, so nice, we don't have to go through all this. Just go to your calculator. You're going to go to stats, test, 2 proportion z-test, or 2 proportion t-test, depending on if you have the standard deviation or not. You're going to input what they ask you for, the P1, the P2, you've got the sample sizes, it's going to calculate for you the proportion, it'll do it all and tell you a p-value, and you reject if it's less than your alpha. All right, all the slides are in the files. I'm here for office hours, questions. Remember, there's not a test on this. We're going to be doing a project on this. I wanted you guys to know about it though. All right, that's all for now. Bye.